2.1 Kinetic Particle Model of Matter. Question 1. State distinguishing properties of solids, liquids and gases. Solids and liquids cannot be compressed, whereas gases can be. Solids do not take the shape of their container. Liquids will take the shape of their container, and gases will fill the volume of their container. Liquids and gases can flow, whereas solids cannot. Number 2. State the term for the following change in state. Solid to liquid, melting. Liquid to gas, vaporization. Gas to liquid, condensation. Liquid to solid, solidification. In terms of temperature, what is absolute zero? Well, it's the lowest kinetic energy level of a material at a temperature of minus 273 degrees centigrade or 0 Kelvin. Question number 4. Describe in terms of the motion of its particles and their collisions with a surface how the particle model can be used to explain pressure. Well, when a particle hits the side of a container, there is a transfer of momentum. This transfer of momentum occurs over an amount of time, producing a force. And as the force is over an area, there is a resulting pressure. Number 5. Describe and explain Brownian motion. Well, the random motion of large macroscopic particles such as pollen and smoke particles, which can be explained by the constant bombardment of smaller microscopic particles. Question 6. Describe qualitatively in terms of particles the effect of the pressure of a fixed mass of gas with a change in temperature at a constant volume. Well, the pressure will increase with an increase in temperature as the particles have got more kinetic energy and therefore more momentum, which is imparted with each collision on the surface. Okay, so what about a change in volume with a constant temperature? Well, by reducing the volume, the probability of a particle colliding with a surface greatly increases. Therefore, the transfer momentum with each collision occurs over a small amount of time, increasing the force and therefore increasing the average pressure. Question 7. An oven has a temperature of 150 degrees. What is the temperature of the oven in Kelvin? Well, to convert from degrees centigrade to Kelvin, you just add 273. So 273 plus 150, you get 423 Kelvin. And then number 8, a plastic sealed container has a volume of 0.25 meters cubed, and the gas inside has a pressure of 150,000 pascals. The container is then crushed to a new volume of 0.12 meters cubed without splitting. What's the new pressure inside the container? Well, P1 times V1 equals P2 times V2. And we're going to rearrange this to make P2 the subject. So 150,000 times 0.25 divided by 0.12, and I get 312,500 pascals, and then we could round that up to 310 pascals.